Imagine a universe where everything is connected, every star, planet, and particle linked by invisible threads stretching across the cosmos. A place where distance doesn't matter, and actions in one corner of the universe can instantaneously influence another. This is not science fiction. This is the strange, mind-bending reality of quantum entanglement. Quantum entanglement is one of the most astonishing discoveries of modern physics. It describes a phenomenon where two or more particles become deeply connected, so that the state of one instantly affects the state of the other, no matter how far apart they are. Albert Einstein famously called it spooky action at a distance, because it seems to defy everything we know about space, time, and communication. At first glance, this might seem abstract, even impossible. How can something on Earth instantaneously impact a particle on the other side of the galaxy? But experiments conducted over decades have repeatedly confirmed that entanglement is real. Photons, electrons, and even atoms behave as if they are part of a unified whole, as though the universe itself is a vast, interconnected network. Entanglement challenges our classical understanding of reality. It hints at a deeper, hidden web that underlies everything, a framework connecting matter, energy, information, and perhaps even consciousness itself. This hidden web may reveal that the universe is far more interconnected than our senses or intuition suggest. In this exploration, we'll dive into the science, the experiments, and the philosophical implications of quantum entanglement. We'll see how it challenges our understanding of space and time, reveals the fundamental role of information, and hints at the possibility that reality itself is woven together in ways we are only beginning to comprehend. Prepare to journey into the invisible threads that connect all things and discover a universe far stranger and more beautiful than you ever imagined. Quantum entanglement is one of the most fascinating and counterintuitive phenomena in the world of physics. To understand it, let's start with a simple analogy. Imagine a pair of gloves, one left-handed and one right-handed. You place the left glove in a box and send it to New York, while you keep the right glove in London. The moment you open your box, you instantly know which glove is in the other box. The gloves are correlated. At first glance, this seems straightforward, but quantum particles behave very differently from gloves. Unlike a glove, a quantum particle doesn't have a predetermined state before it's measured. It exists in a superposition, meaning it can simultaneously occupy multiple states. An electron, for example, might be spinning both clockwise and counterclockwise at the same time, until you measure it. When two particles become entangled, their properties become intrinsically linked. Measuring one particle immediately defines the state of the other, no matter how far apart they are. This isn't just correlation like the gloves. It's a deep, instantaneous connection. Einstein referred to this phenomenon as spooky action at a distance, because it appears to occur faster than the speed of light, violating classical ideas of locality. The first serious experiments testing entanglement were inspired by the work of John Bell in the 1960s. Bell formulated what are now called Bell's inequalities, which provide a testable way to determine whether quantum correlations could be explained by classical local theories. Decades of experiments, including those using photons and atoms, consistently confirmed quantum predictions. In other words, entanglement is real, and the universe behaves in ways that defy common intuition. But entanglement is not just a theoretical curiosity. It has practical implications. In quantum computing, entangled qubits allow multiple calculations to occur simultaneously, exponentially increasing computational power. In quantum cryptography, entanglement ensures theoretically unbreakable communication. Any attempt to eavesdrop immediately alters the quantum state, revealing intrusion. Even quantum teleportation relies on entangled particles to transmit quantum states across space, paving the way for futuristic networks. Beyond technology, entanglement challenges our understanding of reality itself. It suggests that the universe is far more interconnected than classical physics allows. Particles don't exist as isolated objects, but as nodes in an invisible web linking everything together. Some physicists propose that space and time themselves may emerge from these quantum relationships, meaning that entanglement might be a clue to the fundamental structure of reality. Quantum entanglement is a phenomenon that defies ordinary logic, yet it is experimentally verified and technologically revolutionary. It reveals a universe where connections transcend distance, where information and states are shared across space, and where the fabric of reality is far more intricate and mysterious than we could have imagined. Understanding entanglement is not just about understanding particles. It's about glimpsing the hidden architecture that connects all things, from the tiniest atom to the vast cosmos. One of the most astonishing aspects of quantum entanglement is how it challenges our conventional understanding of space and time. In classical physics, everything is local. An object can only be influenced by its immediate surroundings, and information cannot travel faster than the speed of light. Quantum entanglement, however, appears to violate both of these rules. Two entangled particles, separated by vast distances, respond to each other instantaneously. If you measure the state of one particle, its partner reflects the complementary state immediately, no matter if they are a meter apart or a billion light-years away. This phenomenon, which Einstein famously described as spooky action at a distance, seemed impossible when it was first proposed. How could one particle know what the other was doing across the universe without sending a signal? At first, many scientists thought there must be hidden variables, unknown factors that determine the outcomes of measurements in advance. But decades of experiments have largely ruled out these classical explanations, showing that entanglement is a genuine, non-local feature of reality. One of the most striking demonstrations of this non-locality came from Bell test experiments. These experiments test the statistical correlations between measurements of entangled particles. If local hidden variables govern the outcomes, the correlations would obey specific limits, Bell's inequalities. Time and again, experiments have shown violations of these inequalities, confirming that entangled particles behave in ways that cannot be explained by classical physics. In essence, the universe is fundamentally interconnected in a way that transcends ordinary notions of space and time. In recent years, experiments have pushed the limits of entanglement across astonishing distances. In 2017, Chinese scientists used the Messier satellite to entangle particles separated by 1,200 kilometers, confirming that entanglement persists even across Earth-scale distances. These experiments suggest that the universe operates on a level far more unified than our senses or everyday intuition can perceive. Some theoretical physicists even propose that entanglement is the key to understanding the very fabric of reality. Ideas such as the holographic principle suggest that space and time themselves might emerge from entangled quantum states. In this view, what we perceive as three-dimensional space is a projection from a deeper, information-based layer of reality, with entanglement forming the invisible threads that hold it together. Entanglement also has profound implications for causality. While it does not allow faster-than-light signaling in the conventional sense, it implies that correlations exist beyond classical cause and effect relationships. The universe may not be a collection of isolated events, but a vast network of interdependent phenomena, connected in ways that defy our classical intuition. The science of entanglement reveals a universe that is far stranger than anything we imagined. Space and time, long considered fundamental, may be emergent properties arising from deeper connections. Particles are not isolated. They are nodes in a cosmic web. Understanding this hidden web challenges not only physics but also our philosophical assumptions about reality. It hints at a universe where separation is an illusion, where everything is interlinked, and where the very structure of existence is woven together by invisible, instantaneous connections. Quantum entanglement challenges not only our understanding of space and time, but also the very nature of information. In classical physics, information requires a medium, a signal, a wave, or a particle traveling from one point to another. Yet entangled particles appear to share information instantaneously, without any conventional medium, regardless of the distance separating them. This raises profound questions. What is information, and what role does it play in the universe? Some physicists propose that information is more fundamental than matter or energy. The idea, famously expressed by John Archibald Wheeler as it from bit, suggests that every particle, every interaction, and every quantum event is rooted in information. In this view, entangled particles are not just objects. They are nodes in a vast informational network, instantly reflecting the state of one another because the universe itself is a network of information. Quantum information theory provides a framework for understanding this phenomenon. When two particles are entangled, they share a quantum state. Measuring one particle does not merely reveal information. It affects the combined state of both particles. In other words, the information is not localized. It is distributed across the entangled system. This distribution allows for phenomena like quantum teleportation, where the quantum state of one particle is transferred to another distant particle, effectively transmitting information without moving matter. Entanglement also underpins the emerging field of quantum computing. In classical computers, information is processed in bits that exist as 0 or 1. Quantum computers use qubits, which can exist in multiple states simultaneously thanks to superposition. When qubits are entangled, they become part of a shared informational network, allowing computations on a scale far beyond classical machines. In essence, entanglement transforms information from a passive record into an active, interconnected resource. Even more intriguing is the possibility that entanglement hints at a hidden informational web connecting all things. If the universe is fundamentally informational, then every particle, every event, and potentially even consciousness may be linked through this underlying network. The randomness we perceive in quantum events may be a reflection of patterns encoded in this deeper informational layer, and entanglement is the thread that reveals these connections. Some researchers speculate that this informational web may extend beyond physics into other realms, including consciousness and perception. If reality is fundamentally about information, then the mind itself, an interpreter of information, might interact with this network in ways we do not yet fully understand. While these ideas are speculative, they offer a tantalizing bridge between science and philosophy, suggesting that entanglement is not merely a physical phenomenon but a key to understanding the architecture of existence itself. Entanglement transforms our understanding of information from something static and local into something dynamic, relational, and universal. It reveals that information is not just a property of particles but a foundational feature of reality. Each entangled particle is a glimpse into a hidden network that connects the universe, offering a vision of reality as a living, interconnected system where information flows instantly across space and time. The deeper we explore quantum entanglement, the clearer it becomes that the universe is not merely matter in motion. It is a vast, invisible web of information, linking everything in ways we are only beginning to comprehend. Could the invisible threads connecting particles extend beyond the quantum realm, linking our minds to the universe itself? While this idea remains speculative, it has captured the imagination of scientists, philosophers, and spiritual thinkers alike. Some researchers, like physicist Roger Penrose and anesthesiologist Stuart Hameroff, propose that consciousness arises from quantum processes within the brain. According to their theory, microtubules, tiny structures inside neurons, may operate in a quantum regime, potentially allowing the brain to access entangled states. If this is true, consciousness may not be merely a byproduct of classical neuronal activity, but a phenomenon deeply connected to the fundamental structure of reality. Entanglement could provide the link, allowing the mind to interact with the universe at a level beyond space and time. Even without accepting quantum consciousness theories, entanglement encourages a reconsideration of our sense of separateness. Classical physics portrays the universe as a collection of isolated objects, each acting independently. Quantum entanglement, however, shows that at a fundamental level, everything is interconnected. If particles can instantaneously influence one another across vast distances, might consciousness itself be part of this hidden web? Could thoughts, awareness, and intuition be influenced by the same universal connections that govern entangled particles? Ancient wisdom and spiritual traditions have long suggested that all life is interconnected. Modern quantum science may provide a scientific framework supporting this insight. The idea that consciousness is linked to a universal network resonates with concepts such as collective consciousness, intuition, and even psychic phenomena. While these ideas remain controversial, they underscore the possibility that consciousness is not confined to individual minds but participates in a broader, interconnected system. Entanglement also challenges our understanding of cause and effect in consciousness. Classical thought assumes linear causality. One event causes another. But entanglement suggests correlations that transcend time and space, implying that consciousness might interact with reality in ways not captured by linear cause and effect models. This opens the door to exploring non-local aspects of the mind, from intuition to synchronicities, and suggests that our awareness may resonate with the universe in subtle, yet profound ways. The connection between entanglement and consciousness remains one of the most intriguing frontiers of science. It encourages a shift in perspective. Rather than seeing ourselves as isolated observers in a mechanical universe, we may be active participants in a vast, entangled network. Consciousness, like particles, may be linked to a hidden web of reality, where the boundaries between self, mind, and universe are fluid rather than fixed. By contemplating these possibilities, we are invited to see reality not as fragmented and disconnected, but as a living, interwoven system. Quantum entanglement may be the bridge that unites science, philosophy, and spirituality, offering a glimpse of a universe where mind and matter, observer and observed, are fundamentally interconnected. From computing to communication, the principles of entanglement are transforming how we manipulate information, interact with the universe, and even envision the future of human capability. One of the most exciting applications of entanglement is in quantum computing. Unlike classical computers, which process information in bits that are either 0 or 1, quantum computers use qubits that can exist in multiple states simultaneously thanks to superposition. When qubits are entangled, they share a quantum state, allowing computations to occur in parallel across an interconnected network of qubits. This exponentially increases computational power, enabling quantum computers to solve complex problems in seconds that would take classical computers millions of years. Applications range from cryptography and drug discovery to climate modeling and artificial intelligence, potentially reshaping entire industries. Quantum cryptography is another groundbreaking technology relying on entanglement. Traditional encryption can be hacked if an attacker intercepts or copies the signal. Quantum cryptography, however, leverages the fact that entangled particles are correlated in such a way that any attempt to eavesdrop immediately alters the quantum state. This means that any interception is instantly detectable, creating a theoretically unbreakable method of secure communication. Governments, financial institutions, and tech companies are already investing heavily in this technology to secure the next generation of communications. Entanglement also enables quantum teleportation, the process of transferring a quantum state from one particle to another over a distance. While this is not teleportation in the sci-fi sense of moving matter instantaneously, It allows quantum information to be transmitted with perfect fidelity. In practical terms, this could lead to ultra-secure communication networks and the foundation of a future quantum internet, where information is transferred faster, safer, and more efficiently than ever before. Beyond computing and communication, entanglement is being applied in precision measurement and sensing. Entangled particles can improve the sensitivity of sensors, enabling detection of gravitational waves, minute magnetic fields, and subtle changes in temperature or pressure with unprecedented accuracy. These advancements could revolutionize medicine, environmental monitoring, and fundamental physics research. Even more broadly, these technologies hint at a profound shift in how humans interact with reality itself. Entanglement demonstrates that information, rather than matter or energy alone, is fundamental. By harnessing the entangled web of the universe, we are beginning to develop tools that operate in harmony with the hidden architecture of reality, revealing patterns and connections that were previously invisible. The practical applications of quantum entanglement bridge science and philosophy. They remind us that the universe is not a collection of isolated objects but a deeply interconnected system, where the behavior of one particle can influence another, and where information flows in ways that challenge our classical intuitions. As we continue to explore and apply entanglement, we are not only creating new technologies but also learning to navigate and interact with the hidden web of reality that binds all things together. Quantum entanglement, once considered a mysterious quirk of subatomic particles, is now driving innovations that could reshape technology, society, and even our understanding of the cosmos. In embracing these technologies, we are beginning to see a future where the invisible threads connecting everything are not just theoretical. They are practical, powerful, and profoundly transformative. Quantum entanglement is not just a scientific curiosity. It may be a window into a hidden web connecting all things in the universe. If entangled particles can instantaneously influence one another across vast distances, it suggests that the universe is far more interconnected than classical physics or everyday experience would lead us to believe. Instead of being a collection of isolated objects, reality may be a vast network of interdependent nodes, linked together by invisible threads that transcend space and time. Some theoretical physicists propose that space and time themselves may emerge from entanglement. In this view, the three-dimensional universe we experience is a projection of deeper, more fundamental relationships. The holographic principle, for example, suggests that all the information contained within a volume of space can be represented on its boundary, much like a hologram. Entanglement could be the mechanism that weaves together this cosmic tapestry, binding matter, energy, and information into a cohesive whole. This hidden web may also provide a new way to understand patterns in nature. From the coherence of light in lasers to the efficiency of photosynthesis in plants, entanglement may be part of the invisible architecture that organizes complex systems. Even human consciousness could be subtly influenced by these interconnected threads, linking our thoughts, perceptions, and actions to the larger universe in ways we are only beginning to comprehend. Entanglement challenges the notion of separation at its core. Classical physics treats objects as discrete and independent, but quantum mechanics suggests that, at a fundamental level, nothing exists in isolation. Every particle is connected, every event resonates across the network, and every action potentially reverberates throughout reality. This perspective encourages a holistic understanding of the universe, one in which relationships, patterns, and connections are more fundamental than the individual components themselves. Philosophically, the hidden web of reality resonates with ancient wisdom and spiritual traditions, which often emphasize the interconnectedness of all life. The idea that everything is part of a unified whole, once considered mystical, may now find support in the cutting-edge science of entanglement. It bridges the gap between the material and the immaterial, suggesting that reality is not merely a collection of things, but a dynamic, living network of relationships and interactions. In practical terms, understanding this web may transform not only physics but also technology, society, and our perception of existence. By embracing the notion that everything is interconnected, we open ourselves to new ways of thinking, problem-solving, and relating to the universe. The hidden web is not just a scientific concept. It is a lens through which we can view the cosmos, ourselves, and the profound unity that underlies all things. Quantum entanglement invites us to reconsider what it means to exist. Reality is not a fragmented collection of matter and energy, but a living, interconnected system where every particle, every thought, and every moment is part of a vast, invisible web. By exploring entanglement, we begin to see the universe not as separate parts, but as a deeply unified whole, woven together by the threads of quantum connection. Quantum entanglement reveals a universe far stranger and more interconnected than we ever imagined. Particles separated by vast distances can influence each other instantaneously. Information flows in ways that defy classical logic, and the very fabric of reality appears to be woven from invisible threads linking everything together. This phenomenon challenges our traditional notions of space, time, and individuality, suggesting that separation is an illusion and connection is fundamental. Living in an entangled universe transforms how we perceive ourselves and our place in the cosmos. We are not isolated observers navigating a random world. We are participants in a vast, interconnected network. Every thought, action, and intention may ripple across this hidden web, influencing the universe in ways subtle, profound, and often invisible. Our consciousness, like entangled particles, may be linked to this cosmic fabric, resonating with the universe in ways science is only beginning to explore. Beyond science, entanglement bridges philosophy, spirituality, and human experience. Ancient wisdom often speaks of the interconnectedness of all life, and quantum physics now provides a framework that echoes these timeless insights. Understanding entanglement encourages a holistic view of reality, one where relationships, patterns, and connections are more fundamental than isolated components. Quantum entanglement invites us to see reality as a living, interconnected system, where the boundaries between self and universe blur, and every element is part of a greater whole. It challenges us to awaken to the invisible threads that bind all things and to recognize our place within this vast, entangled web. In embracing this perspective, we gain not only a deeper understanding of the universe, but also a profound sense of unity, purpose, and connection that can transform the way we live, think, and relate to the world around us.